Hello, everyone. I'm Ram Chakravarti, the CTO at BMC Software. I'm here today to share my perspective on DataOps as an enabler of success for data and analytics transformations. First, let's tease out why data and analytics continue to be a big deal. Next, let's briefly look at traditional approaches to data and analytics transformations, as well as the challenges that are typically encountered therein. Finally, we'll turn to our recipe for success. I'll introduce DataOps as a concept for enabling value realization for data and analytics transformations, get into some details on the constituent parts, as well as talk about implementation considerations. All right. So I'm kind of stating the obvious when I say that nearly every interaction by nearly every person on the planet leaves a data trail. We can definitely collect all kinds of data, and we can store a lot more data for a lot cheaper than ever before. We can process information way faster and better with the explosive growth in computing. In fact, so much so that the classical Moore's law has ceded turf to the newly emergent Rose's law with the advent of quantum computing as the next paradigm. Finally, we can analyze information more effectively, and this becomes better by the day with the ubiquitousness of AI, even though we are in the early stages of the AI era. So what's behind all this hype? Let's examine some factoids. From a transaction standpoint, there are trillions of data points from customer activities and enterprise systems. Next, mobile devices. There were north of 14 billion mobile devices by the end of 2020, and that's only poised to grow significantly more. But even that dwarfs in comparison when you consider connected devices and IoT. End of 2020 saw 21.5 billion interconnected devices, and that number is set to explode to north of 45 billion such devices by the end of 2021. More than that, let's turn to social media. We won't leave that behind. Facebook users post 5 billion items on a daily basis, and the Twitterati aren't far behind. There are 500 million Twitter posts on a daily basis. If that wasn't enough, we now also have access to previously unavailable information that spans scientific data, geospatial data, satellite imagery, rooftop imagery, genomic data, and a whole host of other kinds of information that simply leave the whole data trail ripe for exploitation. So, it should not come as a surprise to anybody if you consider that data management was the largest area of enterprise investment in 2020. By the way, it was also the largest area of enterprise investment when you look at enterprise software, even in 2019. So the pandemic did not really have an effect on data management. So 2020 saw $73 billion invested in data management in enterprises as about 14% of the total investment in enterprise software. And mind you, that does not even include analytics and BI, which at $26 billion accounted for another 5%. So together, said otherwise, data management and analytics and BI account for nearly 1/5 the total investment in enterprise software in both 2019 and 2020. And it becomes even more significant if you consider a couple of other data points. The $536 billion in enterprise software is just that. It does not include investments in enterprise infrastructure, regardless of the mode of computing paradigm. So investments in the supporting infrastructure for big data and business analytics is not part of this equation, and that's a significant amount by itself. Secondly, if you look at the enterprise applications, analytics and BI spend of $26 billion is only towards standalone analytics and BI. It does not take into consideration the embedded analytics that are present in commercial off-the-shelf solutions, such as CRM, ERP, PPM, SEM, and so on. So this investment is truly staggering. Let's look at what this looks like going forward. In late 2020, early 2021, 451 Research and BMC Software conducted an extensive survey of over 1,200 companies, with each company having at least 500 employees and more than $100 million in annual revenue. These companies span 20 industry sectors and 11 geographies. The questions were asked around the importance of their technology-enabled initiatives to propel them to become autonomous digital enterprises. As the graphic shows, both present and 2 years from now, the imperative to become a data-driven business holds primacy of place in organizations. A separate and independent data point that attests to this just as well is that IDC has estimated that the anticipated spend in big data and business analytics solutions in 2021 in total is going to be $190 billion. And it's expected to grow in double digits through 2022 and perhaps beyond as well. So data and analytics are definitely a big deal. It's not a myth, it's reality. All right, now that we've established these set of factoids that attest to the importance of data, let's talk about traditional approaches. Now, for those of you who've been practitioners of data management and analytics, you would have probably had your share of battle scars from the early days of data warehousing and BI, and now more to the recent data analytics transformations, where AI is a centerpiece. However, there have been fairly traditional, robust approaches that are pretty darn solid. So if you look at one such approach illustrated here, it shows 4 building blocks of data and analytics transformations, and it's pretty all-encompassing at a conceptual level. In that, it includes an overarching data and analytics strategy, the supporting architecture, operating model and organizational considerations, as well as the culture and execution elements. However, if you really look at how many of these initiatives have been successful, it's not too many. At most, a fifth of such initiatives have been successful in meeting business expectations. The graphic paints a pretty grim picture. So you could potentially call it colossal failure, but that's probably a tad harsh. I would characterize most data and analytics transformations as overpromising but under-delivering against what they set out to do. So then the next logical question is, what are the reasons for failure? I'm sure each of you has experienced your own reasons for failure. This is my list of reasons, things that have lived through in failed initiatives, as well as not seen in successful initiatives pertaining to data and analytics. In no particular order, this list of reasons for failure is as follows. Number one, the exploding number of data sources exacerbated by new complex business models make simplification difficult. In fact, there have been a lot of data points from surveys and industry research that point to significant variability in data quality, as well as inconsistent data models that are basically causing this as a point of failure. Second, process mismatch. This is where traditional data management processes, practices, and procedures that have been established in organizations for a fair period of time not lending themselves well to the application of new AI methods. Third, lack of collaboration. You can almost point to this as one of the causes for failure in 90+% of failed data and analytics transformations. This is really a lack of collaboration between the business and IT, which basically stymies the requisite cultural shift that is needed to succeed. Next, significant investments. These are non-trivial initiatives. Each of these requires a 2 to 3 year period to kind of execute from start to full value realization. And anecdotally, for mid-sized companies, it's an investment of $50 to $75 million over this time horizon. That is a significant chunk of money. Next, scarce talent pool in the industry. This is not the case of the demand for data engineers and data scientists being vastly in excess of supply. Yes, that is a problem we are facing. But this is more about a critical path skill, which is a combination of said technical expertise along with the functional domain expertise that is truly needed to be successful. And that's pretty scarce. Number 6, my absolute favorite, last mile delivery challenges. This is basically the inability to scale beyond 1 or 2 use cases and the inability to fully operationalize a set of high-value analytics use cases across business functions, in fact, across the enterprise. And this is primarily because the technology implementation is unable to meet the business demand for flexibility, agility, and ease of configurability. Next, shiny toy syndrome. This is mostly self-inflicted. This is basically technology vendor lock-in early at the genesis stage of the program without significantly investing in program management or collaboration and setting up success pathways or even paying enough attention to how we're going to operationalize. Lastly, many of the data management initiatives are foundational in nature, which means that it is difficult to quantify or monetize said initiatives. So if the approach to measure success is unclear, then how are you going to figure out whether the initiative has been successful or otherwise? All right. So given all of these problems, and I'm sure there are a whole host of others as failure points, the industry has been grappling with what to do in order to be successful, given the amount of investment that's going into this area. So here is where I will introduce DataOps as a new recipe for successful data and analytics programs. DataOps has emerged as a new capability to tackle this very problem. On the left, you have a couple of industry definitions that are pretty solid. However, I have my very own take. I define DataOps as the application of agile engineering and DevOps best practices to the field of data management to rapidly turn new insights into fully operationalized production deliverables that unlock the business value from data. That was a mouthful. Let's make it simple. It's basically DevOps best practices applied to data management for rapid delivery, balancing agility and quality. Okay, now that we've demystified it, let's further disaggregate it into its constituent parts that are critical success factors. I look at DataOps comprising 5 critical components. The first of which is extensive collaboration across the entire ecosystem of stakeholders who can broadly be categorized into data managers and data consumers. Second, pervasive automation. This is an absolute must-have for DataOps, and automation here refers to orchestration, configuration, provisioning, and self-service. Third, process standardization and refinement is absolutely required to retrofit processes and refine processes that support data management practices in order to work for the application of new analytics techniques spanning AI and beyond. Four, the right fit technology. I alluded to it. It is about the right horse for the right course. I'll illustrate the point with a story. A data and analytics leader who I'm well acquainted with has a simple rule of thumb. Anytime an existing analytics use case that is based on a traditional method is identified as a candidate for the application of a new AI-based method, they go through the rigmarole and then they check the results. If the AI method yields an order of magnitude improvement or more than the traditional method, only in such a case they switch to the new method. Else they stick with what's been tried, tested, and proven to work. Seems pretty judicious to me. Speaking of judicious, one should also look at a pragmatic approach to data governance, security, and metadata management so that the organization is not overly burdensome with respect to these practices, nor is it overly lax. And here I'm referring to not just the practices, but also the tools to support data governance, security, and metadata management. Okay. If you really look at DevOps as best practices being applied to data management as the theory behind DataOps, it would be pretty obvious to note that extensive collaboration and pervasive automation being the hallmarks of the DevOps mantra are worth greater examination. So let's do just that. Let's look at both of these, starting with extensive collaboration. Here is a simple use case that underscores the need for extensive collaboration. Across the top in the chevrons, it shows a use case from concept all the way through full operationalization with a whole set of steps in between. But on the left, there's a whole set of stakeholders spanning the business product owners, the digital center of excellence, the analytics community that includes data scientists and analytics translators, the data manager community, which includes the data owners, the data stewards, the data architects, data engineers, and what have you, as well as other constituents such as the security personnel and so on. As you can see, there is a lot of interplay between the various constituent stakeholders for the realization of value from full operationalization of one use case. Consider a scenario where one of these interactions for this one use case is suboptimal. That would delay the rollout and deployment and operationalization and value realization of this use case. Now, extrapolated to multiple use cases, several dozen, perhaps even 50 plus, across business functions, across the enterprise. Is it any surprise that suboptimal collaboration is a point of failure in that the initiative does not meet business expectations? The point I'm making here is that there is a need for even greater collaboration than ever before. And truly, everybody needs to have an ownership mindset from business through the IT constituents. And I'd lump them in two groups: the data managers, who are basically the data owners, the data stewards, the data architects, and the data engineers, as well as the data consumers, who are the business owners, the power users, the light touch end users, and the analytics community that includes the data scientists. In absence of such a collaboration, an initiative is basically going to stall and not be successful. Okay, I've said my piece about extensive collaboration. I'm going to turn your attention to pervasive automation. And to do so, I'm going to use a simplified DataOps market model. At the bottom, in the dark blue, you see the foundational infrastructure as well as the data processors. These are commoditized. And basically, when you're talking about automation here, you're referring to provisioning, configuration, and self-service. The core of the data pipeline is a set of eclectic components, from ingestion of data from a multitude of sources to the integration, aggregation, harmonization, application of data quality, testing, deployment, and monitoring of the pipeline health and performance. Of equal importance are metadata functions, cataloging, lineage, what have you, as well as data governance and security. If you look to the left, we basically have two distinct buckets of data sources. One, the traditional set of data sources, and two, the emerging set of data sources that are ripe for exploitation for monetizing data as an asset. On the right, you have, again, two sets of data consumers. One is the traditional consumers, the analytics, the BI, visualization folks. And the second is the advanced analytics and the data science folks, who themselves have led to a new capability called MLOps, which is a close cousin of DataOps. But enough said. If you look across this continuum, there is actually one puzzle piece that goes across all the way and enables end-to-end automation. This is data pipeline orchestration. Data pipeline orchestration is the one component that stitches together the various constituents in a complex data pipeline and is singularly responsible for translating from source into fully operationalized, actionable insights. So it should come as no surprise to you that with the emergence of DataOps as a new capability to tackle this conundrum about failed data and analytics programs, as it has become prominent, orchestration too has risen into prominence and is basically becoming a very critical path function in the quest for end-to-end automation. All right, let me actually channel my inner nerd to illustrate the point. Orchestration is the one ring to bind them all in order to realize the quest for pervasive automation. That's the way I look at it. So the takeaway here, folks, is as follows. Data pipeline orchestration is the critical path capability that eliminates data silos and enables end-to-end automation in a complex hybrid IT landscape that even extends to the edge and translates data sources into actionable insights for consumption. Okay, now a story is much more illustrative to make the point than a conceptual architecture diagram. So with that, let me actually use a case study to illustrate the power of orchestration. And this case study is the story of Navistar International. Navistar International is a 120-year-old company, and they make heavy-duty trucks, school buses, and engines for on-the-road vehicles. They have two sets of customers. One is fleet owners, a set of fleet owners across the globe, and second is a global network of dealers. So Navistar basically was a $10 billion enterprise that wanted to stay ahead of its competition. So in the early to mid 2010s, they started to think about how they could evolve and become a digital company. They launched this program called the On Command program, which was to basically connect the entire ecosystem of their stakeholders and provide differentiated information as a paid for digital business offering that would reduce downtime and promote efficiencies across the entire value stream. And as this solution evolved and they were looking at technology enablement, they basically installed sensors across 350,000 trucks and embarked on a pretty complex analytics use case that would get IoT job stream data and marry it up with a whole bunch of internal other information and provide absolutely wonderful vehicle utilization and service information to the fleet owners. They used BMC's Control M to integrate, automate, and orchestrate this really complex data pipeline with a combination of real-time, event-driven, and time-based processes. The outcomes were phenomenal. They were able to get access to more than 20 million IoT records on a daily basis and turn those into providing real-time vehicle utilization information to fleet owners so that they could predict as well as advise service owners on which parts had wear and tear, which warranted repairs and maintenance, and better still, they were able to connect them to the optimal dealer locations with the goal of minimizing the downtime. The outcomes were stupendous. It resulted in a 40% reduction in vehicle downtime, 80% reduction in unplanned downtime, and 5 times faster delivery of actionable insights. That is compelling, if I say so myself. Now, let's look at other areas of differentiation when it comes to pervasive automation. And mind you, this is not exhaustive. This is the same market model that I shared with you a couple of slides back. First, feature stores. Feature stores are hubs that store and disseminate features that can be used to train machine learning models based on historical data, as well as make predictions using on-demand and real-time data. Next, data pipeline monitoring. It's a capability that is to measure the health and performance of a complex data pipeline or the set of complex data pipelines and organizations that straddle a complex hybrid, even more complex hybrid IT landscape that includes hyperscalers, virtual private clouds, on-prem data centers, and the venerable mainframe, and more now extending to the edge. Next, building on data monitoring, the holy grail is really data pipeline optimization. Imagine if instead of trial and error, individual hypothesis testing, what if analysis, and what have you, you could apply AI to optimize the health and performance of a complex data pipeline or the entire set of complex data pipelines in your ecosystem. And perhaps as an even next step, improve the configuration of the supporting data systems in your enterprise or even a subset thereof. That would be nirvana. So the reason I'm talking about these is these are some of the exciting organic product innovations that are underway at BMC, within the BMC Innovation Labs and across our business units as we step up on our data mandate. Our aspiration is basically to be the strategic partner to enable organizations become data-driven businesses as part of their quest to become autonomous digital enterprises. And that's at the heart of this really new set of exciting innovations that are underway as well as set to come your way in the not too distant future. I am super excited for that. All right, now let's finally turn our attention to implementation considerations. As with any new capability, you really need to think about introducing and adopting and institutionalizing DataOps in digestible bites in your organization. It is a multi-year journey. Take it in digestible bites is the point I'm making. Now, there are a lot of words on this page. I'm not going to read all this out. Let me distill it into 3 succinct points. Number 1, in the near term, introduce DataOps in 1 or 2 use cases, maybe 2 or 3 use cases if you're a little more risk-taking, and focus on collaboration and automation. Learn from these use cases, and it's okay if you fail in 1 or 2, but basically the idea should be as follows. What helped realize these as quick wins? What needs refinement? That's point 1. Next, once you've refined these over the midterm, increasingly apply these across a whole set of use cases and slowly introduce additional DataOps capabilities, small chunks at a time. as you extend it across business functions and throughout the enterprise. Number three, in the long term, as you attain steady state, systematically introduce newer data ops capabilities as business as usual. If you follow this pragmatic approach, the likelihood that your data and analytics transformation is successful with the adoption of data ops is almost guaranteed. In closing, I want to leave you with two thoughts. One, if you haven't already, please visit the BMC Innovation booth in this virtual exchange event, where we have a whole host of exciting product innovations, inclusive of those in the data ops arena for new capabilities we're introducing to our customers. Second, and lastly, actually, I wish each and every one of you the very best in your very own data and analytics transformations. And I look forward to hearing your own data ops success stories next year and thereafter at the next set of virtual exchanges. Thank you and have a wonderful rest of the day.